Page 194. What causes seasons? Many places that are far from Earth's equator and its poles have 4 distinct seasons: winter, spring, summer, and autumn. But there are differences in temperature from place to place. For instance, it is generally warmer near the equator than near the poles. Why? How sunlight hits Earth. Figure 3 shows how sunlight strikes Earth's surface. Notice that near the equator, sunlight hits Earth's surface from almost overhead. Near the poles, sunlight arrives at a steep angle. As a result, it is spread out over a greater area. That is why it is warmer near the equator than the poles. Earth's tilted axis. If Earth's axis were straight up and down relative to its orbit, temperatures in an area would remain fairly constant year-round. There would be no seasons. Earth has seasons because its axis is tilted as it revolves around the sun. Notice in Figure 4 that Earth's axis is always tilted at an angle of 23.5 degrees from the vertical. The North Pole always points in the same direction. As Earth revolves around the sun, the north end of its axis is tilted away from the sun for part of the year and toward the sun for part of the year. Summer and winter are caused by Earth's tilt as it revolves around the sun. Around the equator, the red line in the picture right here, it's getting a lot of direct sunlight. This is what you would feel at noon in the middle of summer, where the sun is hot and directly overhead. Now towards the poles, up here towards the North Pole, and down here, now near the South Pole, the light spreads out and hits at an angle. It's indirect sunlight, so it doesn't feel as hot. It's spread out. This is like what you would feel in the morning or at night as the sun starts to go down. It feels a lot cooler than it does in the middle of the day when the sun is directly above you and hitting you in a direct, constant line. June. In June, the north end of Earth's axis is tilted towards the sun. In the northern hemisphere, the noon sun is high in the sky and there are more hours of daylight than darkness. The sun's rays are concentrated. It is summer in the northern hemisphere. At the same time, south of the equator, the sun's energy is spread out over a larger area. The sun is low in the sky and days are shorter than nights. It is winter in the southern hemisphere. If we live right here in the United States, right now it is tilting, even as it rotates around its own axis. We are generally facing toward the sun, so we're getting as much sunlight as we possibly can. The southern hemisphere spends more time facing away from the sun, so it's cooler on the southern half. It's the opposite over here in December. In December, people in the southern hemisphere receive the most direct sunlight, so it is summer. At the same time, the sun's rays in the northern hemisphere are more slanted and there are fewer hours of daylight, so it's winter in the northern hemisphere. So we're up here and we're generally facing away and we're getting lots of indirect sunlight. So it's spread out over this large surface instead of hitting directly. But you'll notice that no matter where we are in our revolution around the sun, the equator is always getting direct sunlight. Now, in the summer, we're facing toward the sun. As we continue to revolve around, the axis is still facing the same direction. Right here, the axis is not pointing towards the sun, but it's not pointing away yet. So this is sort of where we're starting to freeze. We have our summer and things are starting to cool down. This is fall. It's when the leaves start to die and things start to cool down. This is September. And as we continue to move, we reach winter. And this is where the northern hemisphere experiences our snowy, cold winters. But as we continue to revolve around the sun, we hit March, which is spring. And as we start to warm up, our ice melts and the temperatures rise. And this is where we experience spring with lots of storms. And then we move back into the heat of summer.